Hey y'all, how are you? We are on our last topic of the year. I think it's going to take 2 videos, but anyway, we're going to get started. This is a topic I really wish that you were in class for because I would like to do some things with you, but I'm going to do my best to get it across in a video that you can watch so at least you get a basic understanding. First of all, make sure you have your formula sheet, right? This is all the stuff that we need. We're in Unit 9. You know, you should have all these written down. If you don't, pause this and make sure you get them written down, okay? All right, moving on. We've been talking about inference. And what is inference? We've talked about it a couple days, and that's where we use data from a sample to draw conclusions about a population, right? So we use, data from a sample, because we always have a sample, right? We don't have a population, to draw conclusions about population. Should say a population, but I knew I'd run out of room. Okay, so we use data from a sample to draw conclusions about a population. We want to know, do people like Starbucks or Dunkin' Donuts or this or that? So we get a sample. We were talking about confidence intervals. Now, the goal of a confidence interval, which was our last couple of lessons, is to estimate the population parameter. Okay? In other words, we want to know, we want to say, hey, I'm 95% confident that between 40 and 60% of people do this. So that's what we've been doing. What we want to look at today is we want to look at significance testing, where we assess evidence provided by the data about a claim. In other words, we look and we say, okay, we're sure, and we want to know, does this data mean something? Is it significant? If 3 of us show up at the movies on the same time at the same theater, is that coincidence or is it statistically significant? And this is something we haven't done yet. So we want to put numbers to it and say, is this meaningful or isn't it? So really, a significance tests, they are used to assess the evidence provided by data about a claim concerning a population. Like, you think people prefer Starbucks, or you think they like Dunkin' Donuts. Okay? So what this is all about is we're going to make a claim and say, hey, I think this is true. And then we're going to test it and say, no, that claim is true or false, right? So an outcome, right, that is very unlikely if a claim, I'm trying to use different colors so you could see these. An outcome that is very unlikely if a claim is true is good evidence that a claim is not true. Boy, that sounds crazy, doesn't it? What that means is, if we do the statistics and we say it's very unlikely that this would happen, then the claim is not true. Okay? So A couple of little vocabulary words. The claim that's being tested is the null hypothesis. You know, if I said 90% of people prefer Starbucks, then that would be my null hypothesis. The symbol for that is this. It's H with a little 0, and it's pronounced H naught. Those of you who are my physics wizards know the naught symbol. The test is designed to assess the strength of the evidence against the null hypothesis. The claim about a population that we are trying to find evidence for is called the alternative hypothesis and is represented by a capital H with a little a. So look at those and know that this is the null hypothesis. This is the alternative hypothesis. Now there's a couple of important things about those. HO has an equal sign. Okay. HA never has an equal sign. Okay. So HA could look at something like, examples of an HA could be P is not equal to some number. We'll get a number in a minute. Or we could say P is greater than a number, or we could say P is less than a number. Those are all alternative hypotheses, okay? So anyway, we'll look at those. HO has to have some kind of equal sign, okay? So let's actually do, whoops, whoa. Let's do a sample. This has been kind of wordy so far. So let's actually do a problem and see what the numbers look like. Suppose John Mayer claims that half the population prefers Pepsi and the other half prefers Coke. So John Mayer claims that half the population prefers Pepsi. So our P is equal to 0.5 because half would be 0.5. So that's our P. You think it's higher, okay? So let's say that you think it's higher. It could be lower, whatever, we just need something. Maybe you're thinking that 80% of the people or whatever. So he goes on stage and says, half the people like Pepsi. And you're like, all my friends love Pepsi, it's higher. So what are you going to do about that? You're going to take a random sample. So you take a random sample of 50 subjects, you have them do a blind taste test, and you discover that 36 out of 50 prefer Pepsi. So that's 36 out of 50 equals, put that in your calculator, 0.72. So that's 72%. So P hat equals 0.72, right? And you're like, well, I better do this again. I don't know. So you go take another 50 subjects and have them do a blind taste test, and you discover that 28 of 50 in this particular test. P hat is never going to come out to be the same, right? That's what, 0.56 if you type it in? Or 56%. So here, this P hat of this sample is 0.56. What is the claim? Well, John Mayer's making this claim. The claim is H naught, right? Or H with a little O, and you must write it like this. He claims that P equals 0.5. And you, right, you think it's higher. So you are the alternative hypothesis, and you said, P is greater than 0.5. Okay, does that make sense? this is what you think or your argument, your alternative hypothesis. This is what he claims. You are trying to prove that you're right. So let's look at the sampling distribution. What do we need to do for a sampling distribution? Well, we know that's the normal curve, right? And here John Mayer says that 0.5 is the middle. That's his claim. So we need to fill in our standard deviations, correct? This is, again, good practice with this. How do we fill in our standard deviations? Well, we have to find the standard deviation. What's the standard deviation? You have it written down on your sheet, okay? Square root of PQ over N. So P is 0.5 because he said that 0.5, that's our P. So Q is 1 minus P, so that's 0.5. All over N, we did a sample of 50. So punch that into your calculator. I already did it to save time, right? So now we got to write these in. So 0.5 plus 0.07, 07. So you're going to add and subtract. Of course, you know how to do that. What is that? And let's see. I got to add those on. 0.5707 plus 0. Y'all have to catch me if I type a number in wrong. And if we take 5 minus 0.07, that's 0.4293. .3586. Right, so we put those in. So if the claim is true and we tested random samples, P hat would vary from sample to sample according to the normal distribution, right? So 95% should be in between here, 68, 95, 99.7, right? And we came up with 56. That's 56 right there, right? So our orange one. Well, maybe a little closer over here, right? So if you look at my orange, the 72 would be way over here, right? That would be the 72 mark. So we're already starting to think that something's going on here. So what does the data tell us? Well, we actually have to find the probability. So we're going to use our Z table. Okay, so let me write these down. I'm going to do the orange one in orange. So if you remember what Z is the sample mean minus the mean over the standard deviation. We need several things to put this together. So my orange Z is going to be what? 0.56 minus 0.5 all over 0.0707, right? And that, if you type it in, is 0.8487. And then we've got our other sample that we did, right? I'm going to put Z2 there because that's the second sample we took, and I'm going to call this Z1 because it's the first sample that we took. Is what? 0.72 minus 0.5 over the standard deviation. Now you pull out your Z table. Do you remember how? You want greater than, right? So remember, we're going to look that number up on your Z table, and the Z table always reads to the left. So if you want the right, you have to do 1 minus, right? So look up on table. And if you look it up on the table, it's 0.8023, and y'all know how to do that. So we take 1 minus 0.8023, which equals, what is that? 1 minus 0.1977. So roughly 20%. Now let's look at the green one. I looked this up, right? Look up, and we get 0.9991. And your claim, you think it's greater, higher. So we're going to take 1 minus 0.9991, and that is what? 0.1%? So roughly 0.1%. Okay? So what is your conclusion? Does the outcome support the claim? The evidence does not support his claim. There's only a 0.00, basically, is this decimal, which is 0.1%, right? So what that says is that there's only a 0.1% chance that the evidence does not support his claim. In other words, if he was right, then about half the people you sample should like Pepsi and half should like Coke. But in your sample, 72% and 56%. So there's only a 20% chance that this would happen by chance. And there's only a 0.1% chance that if he was right, that this would happen. This number's too low. He is wrong. Okay? Can we be absolutely certain? Well, we are pretty certain. And I'm going to give you numbers in our next lesson about what percents you can accept. Are we ever 100% certain? No. In this one, we're pretty certain, and I'll explain that more. What are the chances that our result happened by chance? Well, for the green, for that sample, 0.001%. Okay? Does that make sense? All right, I'll let you think about that for a minute. And in our next video, there's not homework to go with this. I just want you to kind of run back through and make yourself familiar with all that vocabulary. I know this is kind of, I really wish we were in class together, but we're not. So I'm going to do the best we can to make you understand this. Read back through that and make sure you understand. He made a claim. We thought it was higher. We took some samples. We checked the z-score. The z-score and the percent that would happen by chance was so low, right, from our sample that we're like, no, you're not right. 50% is not correct. Okay? So I will see you again next time on our next video. Adios, amigos.